Hello children, this is class 10 mathematics, assertion and reasoning questions, chapter 2, polynomial. We already know in our question pattern, total marks are 80, first 20 questions are MCQs. In that, question number 19 and 20 are based on this assertion and reasoning. In assertion and reasoning questions, you will be given two statements. One is an assertion, another is a reason. For that, four options will be given. Option 1 will be both A and R are true. A means assertion, R is reason. Both are true and R is the correct explanation of assertion. Then the second option is both A and R are true, but R is not the correct explanation of the assertion. Third is A is true, but R is false. Fourth is A is false, but R is true. So, in these four options, if you observe option 3 and option 4, any one of the given statement is false, right? So, if any one of the statement is false, directly we'll go and opt option C or D. If both are true, we will check the connectivity between those two statements, whether the reason is helping the assertion, supporting the assertion, connecting the assertion. If it is get connected, go for option 1, that is A. If it is not get connected, go for option B. So this is the way you can answer assertion and reasoning question. When I talk about the connect, the explanation, how do we judge whether the reason is supporting the assertion? For that we have a clue that is called cute. That means generally reason is the explanation like thing for the assertion. So the reason connects the assertion, or the reason is used in the assertion, or the reason tells about the assertion, or the reason explains the assertion. Either it connects or uses or tells or explains the assertion. So the main part is the reason. So the very simple and easiest technique to solve this A and R question is first check the reason statement. If the reason is false, just go for option C. No need to check any other thing. Suppose the reason is true, check the assertion. If the assertion is false, go to option D. If the assertion is true, now reason is also true, assertion is also true, check the connect between them. If they are connected, go for option A. If there is no connect individually, both the statements are true, go to option B. Understood? Now the practice questions. Question number 1. The assertion is P of x equal to 4x cube minus x squared plus 5x power 4 plus 3x minus 2 is a polynomial of degree 3. Reason: the highest power of x in the polynomial P of x is the degree of the polynomial. The highest power is called degree. Yes, this is a true statement. It is a definition for a degree, right? So reason is true. Assertion. When you check the powers of the assertion, the power is 4 here. The power is 4 here. Highest power is 4. But they have mentioned the degree is 3. Actually, the degree should be 4. So, assertion is false. Once any one of the statement is false, we will go for option 3 and 4. Here, assertion is false. So, option D. Correct option is D. You need not check reason. But as per procedure, first we check the reason, then we go for assertion. That's why we checked here. Suppose if the reason is wrong, You need go and check the assertion. Directly you can declare that the R is false and true is assertion is a true statement. Go for option C. Okay, like that you can solve. Now question number 2 is assertion is x cube plus x has only one real zero. Reason, a polynomial of nth degree must have n real zeros. When you talk about this reason particularly, it is a true statement. It is a true statement. When it is a true statement, see here a polynomial of nth degree must have n real zeros. Must have at most n real zeros, not exactly n real zeros, at most. So, at most, suppose the degree is 3 means at most 3 zeros you will get. Okay, at most n real zeros. If the word at most is there, the reason is true. It is not present in this reason, so it is a false statement. Once the reason is false, go for option C. So the correct option is C. Even though if you want, you can check the assertion because both the assertion and reasoning is false. There is no such declaration in our answer. So no need to check. But I'm telling here the reason for this. X cube plus x, no, when you take x as common, it becomes x cube plus x square plus 1 which is equal to 0. Right? Then x is 0, x square plus 1 is 0, x square plus 1 is 0 means x square equal to minus 1. This will become x square equal to minus 1. Any square number will not be minus 1. So it is not a real number. It may be an imaginary number. So the assertion is false. But you need not declare it as false. Just as the reason is false, you just go for option C. It is not necessary to check the assertion. Sorry. The assertion is true because it is telling one real zero. Yes, x equal to 0 is the only real zero. The other zeros are here. X square equal to minus 1 is a imaginary number. So, one real zero is there. So, assertion is true. But you need not check this. Just directly as the reason is false, you can go for option C. Question 3. If one zero of the polynomial p of x equal to k square plus 4 into x square plus 13x plus 4k is reciprocal of the other. If one is the reciprocal of the other, when the zeros, connection between the zeros, what do we do? If reciprocal means the product will become 0. Additive inverse means the summation becomes 0. Like that we will check. Now we go for reason. X minus a is a factor of p of x. Then p of a equal to 0. A is the 0 of p of x. Of course, if x minus 2 is a factor, we will equate it to 0 and we declare x equal to 2 is a 0 of the given polynomial. So the reason is a true statement. Now you go for assertion. K square plus 4 into x square plus 13x plus 4k. Here, if they mentioned that the zeros are reciprocal of the other. If alpha is alpha, then the second zero will be 1 by alpha. So alpha into 1 by alpha, alpha and alpha will get cancelled, only 1 is remaining. Okay, so the product of the zeros is 1. Now you see you see the product from the given equation. It is nothing but 4k by k square plus 4. So you take k common from these two statements. Can k square plus 4 you cannot take common, just do cross multiplication because already alpha into 1 by alpha or a into 1 by a has become 1. So 4k by k square plus 4 equal to 1. Cross multiply it. You will get a quadratic equation when you transpose all the terms. Solve this. You will get k minus 2 the whole square is 0. So k minus 2 is 0. Then k equal to minus 2 will go to that side and become plus 2. K equal to 2. So this is also a true statement. Both the statements are true. When both the statements are true, try to find the connectivity between these two statements. Now, I'll check. The reason is telling about the factor. Okay, it is actually nothing but the factor theorem. But the assertion is about the relation between the zeros, relation between the factors. So they both individually true statement, but each one is not using the other. The reason is not a correct explanation of the assertion. So I opt option B. Question 4. The graph y equal to f of x is shown in the figure. For the polynomial f of x, the number of zeros of f of x is 3. The reason is the number of zeros of the polynomial f of x is the number of points of which f of x cuts or touches the axis. So reason is a true statement. So reason is true because yes, it is the explanation when you geometrically find the zero of the given polynomial. How many places it touches or intersects the x-axis, that many zeros are there for that particular polynomial. If it is a case here in this given attached diagram, in how many places it is moving, it is touching, see here it is intersecting point 1, here it is touching point 2, here also it is touching point 3. So in 3 places it touches the x-axis, so the number of zeros are 3. So assertion is also 3. Now the reason is also explaining the assertion. So the reason is the correct explanation of A. I'll go for option A. Question 5. The degree of 0 of polynomial is not defined. Degree of 0 polynomial is not defined. Degree of a non-zero constant polynomial is 0. Here both are a property statements. Check the reason. The degree of a non-zero constant polynomial. Constant polynomial is nothing but the constant. So what is the power of the constant or degree of the constant here? Any constant, we can imagine some variable with the degree 0 is there, with the power 0 is there. So for this function, the power is 0, the degree is 0. Yes, the reason is true. Then the degree of 0 polynomial is not defined. What is 0 polynomial? For any term, any polynomial, if the coefficient is 0, it is a 0 polynomial. Just you tell about the number 5, degree of 0 polynomial. Yeah. So x square. X square is a polynomial, but the 0 polynomial means the coefficient is 0. So when the coefficient is 0, it is multiplied and becomes 0. The power can be any number. 0x power 5, 0x power 4, 0x power 2, 0x power 1, 0x power 0. You can give any power to the variable because when it is multiplied by 0, it becomes 0. So assertion is also a true statement. But reason is talking about constant polynomial. Assertion is talking about 0 polynomial. Both are different. Each one is not an explanation of the other statement. So I go for option B. And 6. 1 and minus 4 are the zeros of the polynomial x square plus 3x minus 4. The reason is a real number k is said to be a 0 of polynomial p of x if p of k equal to 0. Now the reason is a real statement because any number is declared as 0. When you substitute the 0 in the given polynomial, it should result 0. Then only the number which we have substituted is considered as 0. So reason is a real statement. Then you go to the assertion x square plus 3x minus 4. In that substitute 1 and check, yes, it gives 0. In that you substitute minus 4, f minus 4 equal to minus 4 square plus 3 into minus 4, you are getting 0. So both the numbers are the zeros. By factor finding method we have checked, factor theorem method. Okay, yes, both the statements are true, and here we are using the reason to understand the assertion. It is used. So both are true. Correct option is A, because reason is the explanation, correct explanation of assertion. Question 7. The graph of a polynomial p of x is a straight line parallel to x-axis. Okay, here I have drawn. This is x-axis, sorry, y-axis. This is x-axis. This is the record graph. The green color is the record graph. It is parallel to x-axis. The polynomial has no zero. Why it is declared no zero? Because it doesn't intersect x-axis at any place. So as there is no intersection point, no reason. So reason is 0. The reason is, if a polynomial p of x does not intersect x at any point, it does not have any 0. Right away, the statement, the reason statement is an explanation to the assertion. Both are true, and reason is the correct explanation to the assertion. We can see this through this graph. So go for option A. Assertion. The sum and the product of the zeros of quadratic polynomial are 1 by 4 and minus 1 by 4. Then the quadratic polynomial is 4x squared plus 4x plus 1. Now the reason is the quadratic polynomial whose sum and product of the zeros are given x squared minus sum into x plus product equal to 0. That is a reason. Yes, the reason is a formula to find the equation using the zeros. Okay, so reason is a true statement. Go for assertion. The assertion, they are telling two zeros, 1 by 4 and minus 1 by 4. If you find the sum of this, the summation becomes 0. Oh, directly they have given the sum is 1 by 4 and the product is minus 1 by 4. So x square minus sum of 0 into x plus product of 0. Here you substitute 1 by 4. In the product you substitute minus 1 by 4. So both the terms are having a denominator 4, common multiply by 4. So 4 into x square will become 4x square minus 1x plus 1 minus 1 equal to 0. Okay, 4x square they are finding the polynomial. When you multiply it by 4, actually x square become 4x square and 1 by 4x will become 4 and 4 get multiplied and becomes minus x. Actually this question it should be minus x. Okay. Then both are true and reason is the proper explanation of assertion. So we go for option A. A polynomial having variable with the power 0 or only with numerical term is called constant polynomial. In a constant polynomial, we know imagine the variable is with the power 0. So we can consider that the power is 0 and it is also a numerical term itself, right? So the assertion is perfect statement and it is true. The reason is a constant polynomial has highest degree is 2. Constant polynomial means just now we checked that degree or the power should be 0. 5x power 0 is nothing but number 5. So both the statements are constant polynomial has highest degree 2. The reason is false because constant polynomial means just now I told 5x power 0 is constant polynomial, right? So the degree is 0, it's not 6. So as the reason is false, we go for option C. Assertion, the product of the zeros of the equation 2x squared plus 8x plus 6 is minus 3. The product product of 0. Okay. Then reason is for a quadratic polynomial ax square plus bx plus c equal to 0. The product of zeros is c by a. Of course, from the quadratic general term, the sum of zeros is the middle point minus b by a, and product of zeros is the constant point c by a. So the reason is true. The assertion is 2x square plus 8x plus 6. The product of zeros is 3. What is the product of 0? C by a. So 6 by 2. 6 by 2 is 3. It is not minus 3. So assertion is false. If assertion is false, we directly go and land up on option D. Hope this video will be helpful to you children. Do well your exams. All the best for your exams.